Hello students, welcome back to the classroom point. In our today's class, we shall discuss the redox reactions. This redox reactions is very helpful in solving the stoichiometric calculations and also in inorganic chemistry. Let's begin the topic now. Redox reactions. So the redox reactions means the reactions in which both reduction and oxidation takes place simultaneously, known as the redox reactions. So let us try to see what is the definition of the oxidation and reduction. So first of all here, oxidation. Then let us see how many ways this oxidation can be defined. The first one is addition of oxygen. Is called as the oxidation. So let us take an example. Take the magnesium and add oxygen to this magnesium. We get magnesium oxide. Since oxygen is added to the magnesium, this is called the oxidation. You can take sulfur, add oxygen, gets the sulfur dioxide, or else take the methane and add the oxygen to get the carbon dioxide and water. Or else you take the SO2 plus O2 gives rise to SO3. So in all these reactions, oxygen is added, hence these reactions are called as the oxidation reactions. So let us see one more. Addition of electronegative element. So when electronegative element is added, that is also known as the oxidation. Take magnesium, add fluorine. Fluorine is electronegative element compared to the magnesium, and here magnesium fluoride. Similarly, magnesium with chlorine gives magnesium chloride. Magnesium with sulfur gives magnesium sulfide. These are all oxidation reactions where electronegative element is added to the less electronegative element. That's why these are known as the oxidation reactions. Now let us see the third type of definition. Removal of hydrogen is also known as the oxidation. So let us see how to remove the hydrogen. Take the hydrogen sulfide, add chlorine, it gives 2HCl plus sulfur. See, hydrogen is removed from the H2S, sulfur is finally produced. So it is called the oxidation. Similarly, take the H2S plus O2 gives rise to H2O plus 2 sulfur. So by replacing the hydrogen, that reaction is also known as the oxidation. Next, removal of electropositive element. So when electropositive elements are removed, those are also known as the oxidation reactions. So let us see here. K4 FeCN taken 6 on reaction with H2O2 gives 2K3 FeCN taken 6 plus 2 KOH. So in this reaction, each of this molecule is having the 4 potassium, but here 3 only there, one of the potassium is removed. So removal of the electropositive element is known as the oxidation. And we can take K2, MnO4, ozone and H2 gets KMnO4 plus KOH. Here 2 potassium ions are there, but here only 1 potassium is the remaining potassium removed in the form of the potassium hydroxide. So these all processes are known as the oxidation process. So addition of oxygen or electronegative element, removal of hydrogen or electropositive elements are known as the oxidation reactions. So let us see now what is the reduction here. So reduction is exactly opposite to the oxidation. Everything we have to study in the opposite way. That means process must be the opposite. Here addition of oxygen is there. Now let us take the removal of oxygen. Is known as the reduction. So let us take an example. Mercuric oxide on heating gives mercury plus oxygen. Oxygen is removed. Similarly, take the silver oxide and heat it. It gives silver plus oxygen. So these are all reduction reactions. Removal of electronegative element is also known as the oxidation here. So let us take HgCl2 is added with SnCl2 stannous chloride, gives Hg2Cl2 plus SnCl4. So from mercuric chloride, there are 2 chlorines with every mercuric ion, but now here 2 chlorines with 2 mercurous ions. So 2 chlorines are removed in the form of the SnCl4. Removal of the electronegative element is known as the reduction reaction. Now, addition of hydrogen. Is known as the reduction reaction. So in this addition of hydrogen, we can take the FeCl3. When added with the hydrogen, we get 2 FeCl2 plus 2 moles of HCl. Hydrogen is added, so it is called as the reduction reaction. Let us take one more reaction here. CH2 double bond CH2 plus hydrogen. It gives CH3 single bond CH3. Addition of hydrogen. Now, addition of electropositive element is known as the reduction. We can take the same reaction here. This is an example of both of these process. So which gives Hg2Cl2 plus SnCl4. So one of the electropositive element mercuric ion is added. At the same time, the same reaction electronegative element also removed. So these are all called as the here up to here oxidation reactions, and remaining are known as the reduction reactions. Apart from this type of the process, oxidation and reduction can also be defined using the electron transfer. Now let us see that part. Oxidation and reduction in terms of electron transfer. So let us see how to define the oxidation and reduction using the electron transfer. First of all, oxidation. Loss of electrons. is known as oxidation. We know that electrons carry the negative charge. So whenever any atom or the species is losing the electrons, means automatically negative charge decrease and at the same time positive charge increase. So decrease in negative charge or increase in positive charge is also to be called as the oxidation. Now let us see that. The decrease in negative charge or increase in positive charge is observed in case of the oxidation. So by taking some examples here, imagine element M lost n number of electrons so that it got the n plus positive charge. Whatever the number of electrons are lost, the same quantity of the positive charge always increases. So example for this is copper lost 2 electrons to form the cupric ion Cu2+. Next, let us take, if you take the different cations, M N1 plus gives M N2 plus. So loss of electrons, how many electrons are lost? That means higher value, N2 value always could be the higher value in the oxidation process. N2 minus N1 number of electrons are lost. Here N2 is greater than N1. Let us take an example here. Sn2 plus converted into the Sn4 plus by losing 2 electrons. So this is the higher value, this is the lower value, loss of electrons. So that is called the oxidation. So this is for the cations. Then what about the anions? An minus converts into the A plus n number of electrons. All the electrons are lost. Example here. You can see here the negative value converted to the 0. Negative to 0 means value increased, so it is an oxidation. So let us take 2 Cl minus ions converted to the Cl2 by losing 2 electrons. 2 electrons in the sense each Cl minus loses 1 electron. 2 Cl minus ions, 2 chloride ions lose the 2 electrons. So finally molecular form of the compound is, molecule is produced, that is Cl2. An1 minus gives N2 minus plus N1 minus N2 number of electrons. Here number wise, not the value wise. Number wise N1 is the higher value, N2 is the lower value, means more negative charge to the lower negative charge. So this value minus this value, that means the loss of electrons are observed. So example here, oxygen 2 minus lost the electron and converted into the O minus ion. You can see here, if you consider the value, then minus 1 is always higher than the minus 2. That's why it is called the oxidation. But here if you want to calculate this number of electrons, only 2 minus 1 electron we got it. So these are all the examples of the oxidation where the loss of electrons are involved. Then let us see the reduction. As I said earlier, reduction is exactly opposite to the oxidation. So here loss of electrons, now reduction means gain of electrons. Gain or addition of electrons. Is called as reduction. So when you are adding the electrons, electrons carry the negative charge. When you are adding the negative electrons, automatically negative charge increases, so that the positive charge decreases. Decrease in positive charge or increase in negative charge is known as the reduction. Decrease in positive charge or increase in negative charge is observed in the case of the reduction. Let us take the same examples but with the reverse process now. So now here take the opposite of this. That means Mn plus n number of electrons, when you add, it becomes n. See here, positive charge to the 0, value decreased. So it is a reduction reaction. Example, Cu2 plus, add 2 electrons and convert into the copper. 2 plus 2, 0. Next one. Same example again now. N2 plus N2 minus N1 electrons gives Mn1 plus. Here, as it is, N2 value is greater than the N1 value, higher value to the lower value now. So, example, Sn4 plus, by adding difference of electrons to electrons, giving Sn2 plus, value is decreased. Now, in the case of the anions, opposite again, addition of electrons, A plus n number of electrons gives An minus. So, example, see here 0 to the minus, value decrease now. So, here we can take the Cl2 plus, 2 electrons are giving 2 Cl minus. Here each chlorine oxidation state is 0. Here chlorine oxidation state is minus 1. 0 to minus 1 means value is decreased. N2 minus plus N1 minus N2 number of electrons gives N1 minus. Here, this value is always higher. In this case, this is the higher value. This is the higher value. This is the lower value. So here we did not mention that this is the N1 is greater than N2. Here also N1 is greater than N2. Example, O minus plus electron gives O2 minus. So basically, loss of electrons is called as oxidation and gain of electrons is known as the reduction. Now let us see how to calculate these values, oxidation values, and what is the oxidation number. Oxidation number or else oxidation state. State means positive or negative. Number means the value of that positive or negative is called as the oxidation number. So basically, oxidation number means it is an imaginary or real charge carried by an atom in a molecule or ion. So when it applies to the ions, it is the real charge. When it is applied to the molecules, it is imaginary charge. That we will see in the rules how to determine that values. So oxidation number basically says that it may be an imaginary value or it may be a real value depending on the type of the species we select. Let us see some rules and how to calculate these oxidation values. So that is rules to calculate the oxidation number. So the first one is, for any element in elemental form or else free state or else uncombined state, so in all these categories, the oxidation state of the element is equals to 0. So what is free state, what is uncombined state, what is the elemental form? Here elemental form and uncombined state almost same. Let us see here. Uncombined state means when you take the single atoms like sodium, magnesium, carbon. If single atoms you have taken, aluminum, etc. For all these elements, oxidation state is equals to 0. They are not in the combined form. They are the single form. Uncombined form, any single atom is present, its oxidation number is equals to 0. Elemental form. So elemental form means usually if any molecule is formed by two or more same atoms, it is called as its element. So for example, if you take H2 molecule, in H2 molecule both are hydrogen atoms only. So for a hydrogen element means we have to write down the H2. Hydrogen atom means only one H. Hydrogen element means H2. So here oxidation state of both of the hydrogen atoms is equals to 0. Similarly, if you take O2, two oxygen atoms, 0. O3, three oxygen atoms, 0. Separate oxidation states we don't take, we take the combined oxidation state. So all oxygen's values are equals to 0. If you take sulfur, all 8 sulfurs oxidation state equals to 0. Phosphorus, P4 equals to 0. Br2 equals to 0. Cl2 equals to 0. So all these are in the elemental form, means they are formed by the same atoms combination. That's why their oxidation state values are always equals to 0. And free state. What are the free states here? If you take the noble gases always available in the singular form. They don't combine with any other elements, most of the noble gases. So helium, oxidation state is 0. Neon, oxidation state is 0. Krypton, oxidation state is 0. So these are all free forms where oxidation state of the atoms are equals to 0. Let us see the second rule. So second rule is about the hydrogen. So hydrogen exhibits how many type of oxidation states? Hydrogen exhibits mainly 3 type of oxidation states. In its elemental form, hydrogen oxidation state is equals to 0. Now, let us take with metals. When it combines with metals, it exhibits a negative oxidation state. Example, NaH, hydrogen oxidation state -1. So with all metals, hydrogen exhibits the -1 oxidation state. Take the potassium hydride. Oxidation state of the hydrogen is equals to 0. Even you can take the magnesium hydride or beryllium hydride. So with all metals, hydrogen exhibits only one oxidation state, that is -1. With non-metals, hydrogen always exhibits a +1 oxidation state. It is the most popular oxidation state of the hydrogen. Example, in H2O, hydrogen oxidation state +1. In NH3, hydrogen oxidation state +1. In H2S, hydrogen oxidation state +1. HCl, hydrogen oxidation state is +1. So in most of the non-metals or p block elements, hydrogen exhibits the +1 oxidation state. Now, let us see the third rule. Third rule about the other elements. Alkali metals. Alkali metals means lithium, sodium, potassium, rubidium and cesium. So all these alkali metals always exhibits +1 oxidation state. Multiple oxidation states are not possible with the S block elements, except hydrogen, which is able to exhibit the 0, -1 and +1 oxidation states. Next one, alkaline earth metals. So beryllium, magnesium, calcium, strontium, barium, all these exhibits +2 oxidation state. Remember that in alkaline earth metals, beryllium is not included, it is a non-metal. Except beryllium, remaining are called as the alkaline earth metals, so that it is second group elements, you can call this one. So all second group elements exhibit the +2 oxidation state. And about the p block elements. So p block elements exhibits the mainly two type of oxidation states. This is the highest oxidation state and lower oxidation state. So this higher oxidation state, how to calculate the higher oxidation state means, higher oxidation state value is equals to number of valence electrons. Lower oxidation state is equals to number of unpaired p electrons. Example, let us take 13th group elements. So 13th group elements, you know that boron, aluminum, gallium, indium and thallium. So these elements electronic configuration, outer electronic configuration is ns2 np1. Here two s electrons are present and one p electron is present. So their least oxidation state is equals number of unpaired electrons, that is 1. And most of these elements exhibits the positive oxidation states. So that's why here it is equals to +1 we can consider. And a higher oxidation state means here two s electrons and one p electron together is equals to 3. So they can exhibit the two type of oxidation states, +1 and +3 oxidation states. And all elements don't exhibit this type of the oxidation state. So up to 4 elements in every group try to exhibit the higher oxidation state, and last element exhibit the lower oxidation state. So thallium exhibits the +1 oxidation state. So in remaining elements also in this similar pattern we have to follow it. Higher oxidation state is equals number of valence electrons and lower oxidation state is equals number of unpaired p electrons. This is applicable only to the p block elements. Next, what other oxidation states we can consider in case of the p block elements? And when it comes to the fluorine, fluorine exhibits only one oxidation state, that is -1. Apart from the -1, fluorine never exhibits other oxidation states. What about the chlorine, bromine, iodine? Though they are the p block elements, they have to exhibit the different oxidation states also. So in halides they exhibit the -1 oxidation states, but with oxygen and fluorine they exhibit the positive oxidation state depending on the number of fluorines or number of oxygen they are going to combine. Next, regarding the oxygen, how the oxygen is exhibiting the oxidation states. Oxygen exhibits various oxidation states. In oxides, oxygen always exhibits the -2 oxidation states. For example, if you take H2O, where oxygen oxidation state is equals to -2, Na2O, MgO, Al2O3. So these are all oxides where oxygen exhibits the -2 oxidation states. Next, peroxides. Peroxides, oxygen exhibits the -1 oxidation states. Oxide ion is O2 minus. Peroxide ion is O2 2 minus. What is peroxide means? If oxygen single bond is present in any molecule, such molecules are called as the peroxides. So from oxygen single bond, each oxygen don't get any oxidation state. That's why the remaining oxidation states are considered as their individual oxidation states. So example, in H2O2, oxygen oxidation state is -1. Na2O2, oxygen oxidation state is -1. BaO2, oxygen oxidation state is equals to -1. These are all peroxides. Next one, superoxides. In superoxides, oxygen exhibits the -1/2 oxidation states. Usually superoxides are formed by the only first group elements. So they are example KO2, oxygen oxidation state is -1/2. RbO2, oxygen oxidation state of, again CSO2, oxygen oxidation state is -1/2. These are all called as the superoxides. Superoxide ion is O2 minus. Means two oxygens are getting the -1 charge. Each oxygen will get the -1/2 charge. And with fluorine, oxygen can exhibit the two type of oxidation states. So here we can write down that. So with fluorine, it exhibits again two type of oxidation states, this oxygen. That is positive oxidation states. Reason is fluorine is more electronegative than the oxygen. Then obviously oxygen has to lose electrons to the fluorine. So oxygen exhibits +1 oxidation state and a +2 oxidation state. This +1 oxidation state is O2F2. +2 oxidation state is possible only in the OF2. And a very interesting thing here is, as we said here in peroxides, oxygen exhibits the -1. O2F2 is also having the peroxy bond, but still it is not called as the peroxide. Why? Because fluorine is more electronegative than the oxygen. That's why it is called the oxygen fluorides, not the peroxides. So in peroxides, here also peroxy bond is present. So here fluorine oxygen is exhibiting the +1 oxidation state. Let us see the another rule. What happens if molecules are not given but ions are given? So for single atomic ions, for single atom ions, whatever the charge they are carrying, it is equals to their oxidation number. Example, Na plus, oxidation number is +1. Mg2 plus, single atom is present in this ion, so it is carrying the two positive charges, so that positive charge. O2 minus, oxidation number equals to -2. So for single atomic ions, the oxidation number is equals to charge carried by the ion. Next 9. The sum of oxidation states of all the atoms is equal to 0 in case of neutral molecule and is equal to charge in case of polyatomic ion. So let us take the example for this point. So example for this is, if you take H2O, H2O is a neutral molecule. So for neutral molecule, here no charge is carried out. That's why here two hydrogens each exhibit the +1, plus it is an oxide, one oxygen, -2 is equals to, here the value is equals to 0. If you solve this, here +2 -2 is also equals to 0. That's why we are getting again 0. So the sum of the oxidation states of all the atoms in a neutral molecule must be equalized to the 0, since it is not carrying any charge. But what happens if polyatomic ions are present? Polyatomic ions in the sense, for example, SO4 2- is there. So in this case, two different atoms are present, but still it is carrying the some amount of the charge. Then oxidation state of, say, one sulfur is present. We don't know what is the oxidation state of sulfur, +X, and 4 oxygens are present. I don't know that oxygen oxidation state also. Usually it is -2 here. So I am taking Y. this value equals to minus 2. So x plus 4y is equals to minus 2. So like this, sum of the oxidation states of all the atoms in polyatomic ions must be equalized to their charge carried by that particular ion. In case of neutral molecules, it must be equal to the 0. Next, the highest oxidation state. The highest oxidation state exhibited by any atom in the periodic table is equals to plus 8. Highest value is only with the plus 8, but all atoms don't exhibit this plus 8 oxidation state. Only few atoms exhibit the plus 8 oxidation state. What are those means? Osmium, ruthenium and xenon. So these elements usually exhibit the plus 8 oxidation state. The oxidation state of metals in amalgams and metal carbonyls is equal to 0. Example, sodium amalgam we have taken. Here both metals oxidation state is 0. Sodium is equals to 0. Mercury is also equals to 0. Zinc amalgam. Zinc oxidation state equals to 0. Mercury oxidation state also equals to 0. So when metals combine and neither of the atoms lose the electrons or gain the electrons, that's why both elements of oxidation states are to be taken as 0. And metal carbonyls. If a complex is formed by only carbon monoxide ligand, such compounds are called as the metal carbonyls. Example, nickel tetracarbonyl is there, where nickel oxidation state is equals to 0. Iron pentacarbonyl is there, where iron oxidation state is equals to 0. Let us see some other examples. So in nitrate ion test, we used to perform the nitrate ion test using the brown ring test. So in that brown ring test, we used to get the doubt about the iron and the nitrosyl oxidation states. So in the brown ring test, both NO and iron carries +1 oxidation state. So let us see how to calculate the oxidation state. This is for the general calculations, and for covalent molecules, how to calculate the oxidation states. So calculation of oxidation state of covalent molecules. So in case of covalent molecules, let us see, usually covalent molecules are formed. Whenever a molecule or compound you are taking, there must be two different elements. If same atoms are participate in the formation of the molecule, then it could be called as an element that we have already seen in the first point, where oxidation state of the both of the atoms to be taken as 0. But if a compound is formed by different atoms, then automatically one carries the more negative charge and other one carries the less negative charge. So let us see here, there are two atoms X and Y. Two atoms are present. Imagine X is having the less electronegativity and as Y is the more electronegative element. So when a covalent bond is formed between the two atoms with a difference in electronegativity, then for every bond, more electronegative element gets the -1 charge and less electronegative element gets the +1 charge. Usually this charge is a polarized charge. Originally minus 1 plus 1 do not exist. That's why in the starting definition we have taken the oxidation state may be an imaginary value. So these are imaginary values. In case of NaCl, for example, Na plus Cl minus ions, complete positive charge and negative charge exist. That is the real charges. So, but in the case of the covalent molecules and coordinate covalent molecules, we have to consider the oxidation state as an imaginary charge. So for every bond, this type of the combination takes place. What happens if a double bond is present between the X and Y? Then for every bond, more electronegative element gets the minus 1, less electronegative element gets the plus 1. So here two bonds are there. That means Y will get minus 2, X will get the plus 2. What about if triple bond is present? So Y, since it's more electronegative, gets the minus 3, whereas X, since less electronegative element, it gets the plus 3 oxidation state. So let us take an example here. Hydrogen cyanide. In hydrogen cyanide, see, carbon is more electronegative than the hydrogen. So that carbon gets minus 1 oxidation state, hydrogen gets plus 1 oxidation state. Now come to this side bonding. Nitrogen is more electronegative than the carbon. There is a triple bond between the nitrogen and carbon. That means nitrogen has to get the minus 3 oxidation state, whereas carbon has to get the plus 3 oxidation state. Now in this case, carbon is taking the electrons from one side and giving electrons to the other side. That's why one of this bond is cancelled by the other bond, or else you can do the simple calculation here. The net value of the carbon is how much? Plus 2 oxidation state. Now let us take another example. BaSCN taken twice. So in this case, barium is connected to the 2 sulfur. Sulfur is connected to the 2 cyanides. As I had given, barium is the second group element, always exhibit the positive oxidation state. If we don't remember that, at least you see that sulfur is more electronegative than the barium. So sulfur will get the minus 1 oxidation state from this bond. Barium will get the plus 1 oxidation state from this bond. And from this bond, sulfur gets minus 1, barium gets the plus 1. Together, barium oxidation state is equals to plus 2. And sulfur carbon. Sulfur is more electronegative than the carbon. So sulfur gets minus 1 oxidation state from the bond, whereas carbon gets plus 1. Here also sulfur gets minus 1, carbon gets plus 1. Together sulfur oxidation state is minus 2. Now carbon, nitrogen. Nitrogen is more electronegative than the carbon, so that nitrogen gets the minus 3 oxidation state, whereas carbon gets the plus 3 oxidation state. Here nitrogen gets the minus 3 oxidation state, carbon gets the plus 3 oxidation state. So oxidation number of the carbon is equals to plus 4. So like this we can calculate the oxidation state in case of the covalent compounds or covalent molecules. We can take H2O molecule also. What we have taken here. So in H2O molecule, directly we can calculate, or else using this concept also we can calculate it. Oxygen is more electronegative than the hydrogen. From every bond it is getting minus 1, whereas the hydrogen gets the plus 1 for every bond. So that together oxygen oxidation state is equals to minus 2. Now let us take NH3, ammonia. So it is having the 3 bonds with hydrogen. Every hydrogen gets plus 1 oxidation state, because since they are less electronegative than the nitrogen. Nitrogen gets the minus 1 oxidation state for every bond. Total value equals to minus 3. Let us see now other oxidation states also. So now let us see the other concept, that is calculation of oxidation state. In dative bond. Dative bond means coordinate covalent bond is known as the dative bond. So here two concepts. Dative bond means one atom donates the electron, the other atom accepts the electron. Donor to the accept. D stands for the donor atom, A stands for the acceptor atom. If donor atom is less electronegative and acceptor atom is more electronegative, then for every coordinate covalent bond formed between the donor and the acceptor, the donor atom gets the +2 charge, whereas acceptor atom gets the -2 charge. Why? Because the dative bond is formed by donation of electrons. Electrons means 2 electrons participate, and that 2 electrons are given by the less electronegative atom. That's why it is getting the +2 charge, whereas more electronegative atom getting the -2 charge. What happens if reverse? That means here donor to the acceptor, but donor is more electronegative now, whereas acceptor is less electronegative. Usually, even though the bond is formed, but more electronegative atom do not donate the complete electrons. So the transfer of electrons is a difficult process and it is negligible also. So that is the reason why for every coordinate covalent bond formed, the value to be taken as 0. Let us take example here. Isocyanide. So in this isocyanide, we know that hydrogen is less electronegative, gets the +1, and nitrogen gets the -1. Here two covalent bonds, nitrogen is more electronegative than the carbon, so that for these two bonds, nitrogen is getting the -2 charge, whereas carbon is getting the +2 charge. But there is a coordinate covalent bond formed between the nitrogen and the carbon, but donor atom is, in this case, is nitrogen, carbon atom is acceptor. But nitrogen is more electronegative than the carbon. That's why from this bond you cannot calculate any oxidation state. So the final nitrogen oxidation state is equals to -3 in this case. So like this we can see the some rules how to calculate the oxidation states. Now let us take some examples and how to apply these rules in those examples. Let us take simple examples. Later we shall increase this depth of the examples. Carbon dioxide, I would like to calculate the carbon oxidation state. As I don't know, I will take it as X plus 2 oxygens, each oxygen -2. Total value is equals to 0. So that here X -4 equals to 0. X equals to +4. NH3. I don't know nitrogen, so that we shall calculate it. Let us consider the nitrogen oxidation state as X. Since only one nitrogen is there, 1X I am taking. Plus 3 hydrogens, 3 plus 1. Total value is equals to 0 here. X plus 3 equals to 0. X equals to -3. NH2OH, hydroxylamine, nitrogen oxidation state. So X, totally 3 hydrogens are there, 3 plus 1, 1 oxygen is there, 1 -2 is equals to 0. So X plus 3 -2 equals to 0. X plus 1 equals to 0. X equals to -1. SO3 2-, sulfur oxidation state. Sulfur, X, 3 oxygens, -2 each one. Total value is equals to charge carried by the polyatomic ion. So X -6 equals to -2, X equals to +4. KMnO4, manganese oxidation state. Potassium, 1 potassium plus 1, 1 manganese X, which we don't know, that's why we have taken as X. 4 oxygens -2 equals to 0. So that 1 plus X minus 8 equals to 0, X equals to +7. Potassium dichromate, K2Cr2O7. Let us calculate the chromium. 2 potassiums, 2 into +1, 2 chromiums, 2X, 7 into -2 equals to 0, 2 plus 2x minus 14 equals to 0. Minus 14 and 2, that is equals to minus 12. Minus 12 becomes the plus 12. So 2x equals to plus 12, x equals to plus 6 oxidation state of each chromium. H2SO4, sulfuric acid. So 2 hydrogens plus 1 plus sulfur x, 4 minus 2 equals to 0. 2 plus x minus 8 equals to 0. X equals to plus 6. Next, HClO4, chlorine. Now hydrogen 1 plus x minus 8 equals to 0. X equals to plus 7 oxidation state. Let us see some different examples now onwards. CrO5. So if you take CrO5, if you calculate directly, you will get the plus 10 oxidation state. But plus 10 is not possible. That we have already said in the rules, the maximum oxidation state can be exhibited by any element in the periodic table is plus 8. Then we have to go through the structures for some examples. So let us see here. Chromium. The structure of this compound is like this, which looks like a butterfly, but actually it is a square pyramidal structure. So in this, there are 4 oxygens with the peroxy bond, oxygen. In peroxides, each oxygen oxidation state is minus 1. Only one oxygen is carrying with the minus 2 oxidation state. So here chromium I am taking as X. 4 oxygens are of one category. So that 4 into minus 1. Only one oxygen is of minus 2 is equals to 0. X minus 4 minus 2 equals to 0. X equals to plus 6 oxidation state. H2SO5. So peroxomonosulfuric acid. So its structure is see here peroxy bond is there. Out of 5 oxygens, 3 of one category and 2 oxygens are of another category. Means these 2 oxygens are carrying the only minus 1 oxidation state here. So let us take here 2 hydrogens plus 1. Sulfur, let us calculate X plus 3 oxygens. 3 into minus 2 plus 2 oxygens. 2 into minus 1. This value equals to 0. So 2 plus X minus 6 minus 2 equals to 0. So that X is equals to plus 6. Next, H2S2O8. This is called the peroxodisulfuric acid. So here the structure of this molecule is you can see here H2S2O8. 8 oxygens are there. Here also similarly, in the case of earlier one, here also peroxy bond is there. Means these 2 oxygens are exhibiting the only minus 1 oxidation state. Rest of these 6 oxygens are exhibiting the each one minus 2 oxidation state. So let us calculate this 2 sulfur oxidation state. 2 hydrogens plus 1 plus 2x plus 2 oxygens. 2 into minus 1 plus 6 oxygens. 6 into minus 2 equals to 0. So 2 plus 2x minus 2 and this is equals to minus 12 equals to 0. So 2x equals to 12, x equals to plus 6 oxidation state. That means each sulfur is getting the plus 6 oxidation state. Now let us see the C3O2, that is called the carbon suboxide. So in C3O2, if you calculate individual oxidation state, oxygen gets minus 2 oxidation state. These 2 carbons are connected to the oxygen, more electronegative, this is less electronegative, plus 2. So here also this is more electronegative, this is less electronegative, plus 2. But this carbon is connected to only carbon so that it gets the 0 oxidation state. And if you want to calculate the average oxidation state means For this one also we calculate the oxidation state. Usually it will not have any oxidation state, but average oxidation state means all the atoms we shall take. So here average means 3x plus 2 into minus 2 equals to 0, 3x minus 4 equals to 0, 3x equals to 4, x equals to plus 4 by 3. So if you share these values among all these three carbon atoms, each carbon gets plus 4 by 3 oxidation state. Next, ammonium nitrate. So this type of the compounds, you cannot take the average oxidation state. Why? Because this exists in the form of the ionic compound, separate entities these are all. So here ammonium ion and nitrate ion, they are separate entities. Separately we have to calculate the oxidation state. We cannot take the average oxidation state for this one like here. Why? Because this is a single entity. Here these are the two different entities. So for ammonium ion we have to calculate oxidation state for the nitrogen separately. That is equals to x plus 4 hydrogens plus 1, value is equals to plus 1. So x plus 4 equals to plus 1, x equals to minus 3. Whereas for NO3 minus nitrate ion, so nitrogen here x plus 3 oxygens, each one minus 2 is equals to minus 1, x minus 6 equals to minus 1, x equals to plus 5 oxidation state. So in ammonium nitrate, nitrogen exhibits the minus 3 and plus 5 oxidation states. So let us see here Br3O8, tribromo octaoxide. Its structure is bromine, so this is the structure of this molecule, where the bromine's attachment is different in all the cases. If you see here, this bromine is attached to this bromine, but from this bromine, if an atom is attached to the same atom, it will not get any charge from that bond because both are having the same nucleus attraction power. So oxygen is more electronegative than the bromine, so that oxygen gets minus 2 oxidation state. So bromine is losing the 6 charges. See here, minus 2, minus 2, minus 2. Then this bromine has to exhibit the plus 6 oxidation state. From every bond it is getting the plus 2. Totally from 3 bonds it is getting the plus 6. So here minus 2, minus 2. This center bromine has to exhibit the plus 4 oxidation state. And here minus 2, minus 2, minus 2. This one also exhibit the plus 6 oxidation states. So the oxidation states of bromine in this molecule is equals to plus 6 plus 4. But if you take the average oxidation state, so average means we have to share these values among all these 3 bromines, so that it is equals to 3x minus 8 into minus 2 equals to 0. So 3x minus 16 equals to 0, x equals to plus 16 by 3. Every bromine is getting its share of plus 16 by 3. Now, let us take the another examples. Pb3O4. Actually, Pb3O4 exists as PbO plus PbO2. In PbO, lead oxidation state is plus 2. In PbO2, lead oxidation state is plus 4. These are individual oxidation states. But if you want to calculate the average oxidation state, that is 3x minus 8 equals to 0, x equals to plus 8 by 3. Similarly, Mn3O4. This also exists in the similar form. So manganese oxide plus MnO2. Here manganese oxidation state plus 2, here plus 4. But if you take the average oxidation state, 3x minus 8 equals to 0, x equals to plus 8 by 3 is the average oxidation state of every manganese. Next one, Fe3O4. Fe3O4 exists as FeO plus Fe2O3. In FeO, iron oxidation state plus 2. In Fe2O3, iron oxidation state is plus 3. Ferrous form and ferric form both are present there. But if you take the average oxidation state of all these irons, you will get again plus 8 by 3 is the average oxidation state. Now let us see bleaching powder CaOCl2. In bleaching powder CaOCl and Cl, this chlorine gets the -1 oxidation state, this chlorine gets the +1 oxidation state, because oxygen is more electronegative than the chlorine. That's why oxygen gets -1, chlorine gets the +1. Calcium is always +2 oxidation state. In NOCl, NOCl exists as NO plus Cl minus ions. So in NO plus, nitrogen oxidation state, X minus 2 equals to +1, X equals to +3 oxidation state. Ki3. So in Ki3, actually it exists in the form of Ki plus I2. So here iodine exhibits the -1 oxidation state, here iodine exhibits 0 oxidation state, potassium exhibits the +1 oxidation state. So individual oxidation states. So combined form, if you want to take the average oxidation state of all these iodines, then potassium is 1 plus 3x is equals to 0. So 3x equals to -1, x equals to -1 by 3. Let us take hydrozoic acid, N3H. So what could be the nitrogen oxidation state? In the similar way here also, 3x plus 1 is equals to 0, 3x equals to -1, x equals to -1 by 3 is the oxidation state. Now let us see S2O3 2-, thiosulfate ion. So in the S2O3 2-, this is the structure of S2O3 2-. So this sulfur gets -1 oxidation state, one sulfur is getting the -1 oxidation state, and these oxygens, every oxygen is -2 only. So here oxygen is more electronegative than the sulfur, so that -2, and this side it is getting the -1. So totally sulfur is losing the charges -2, -1, -2, totally -5 it lost. That means it will get the +5 oxidation state. From this bond it will not get any oxidation state. So sulfur oxidation state is equals to +5 in the center part. 23. S4O6 2-, tetrathionate ion. So in S4O6 2-, we have to see the structure here. See here, 4 sulfurs, 6 oxygens, 2 negative charges. Tetrathionate ion. Middle sulfurs, they get 0 oxidation state. Why? Because they are connected only to the other sulfur atoms. And this sulfur connected to the 3 oxygens through total number of 5 bonds. So this sulfur gets +5 oxidation state. This sulfur also gets the +5 oxidation state. So 2 different oxidation states are present. If you take the average oxidation state, then here we have to take the 4x plus 6 oxygen, 6 into -2 equals to -2. 4x minus 12 equals to -2. 4x equals to 10. So x equals to plus 2.5. Here also we can calculate the average oxidation state. So 2 sulfur, so 2x plus 3 into minus 2 equals to minus 2. 2x minus 6 equals to minus 2. 2x equals to plus 6 minus 2. 2x equals to plus 4. X equals to plus 2 oxidation state. So dear students, I hope you understand oxidation, reduction, electron transfer, and how to calculate the oxidation states for the different molecules and ions. So if you like this video, please do subscribe the channel and share it with your friends. Thank you one and all.